Hello everyone and welcome to our demo video. Today we are presenting our Seismic activity logger, a complete hardware and software ecosystem designed to detect, analyze and log vibration events in real time. At the heart of our system is an STM32 microcontroller for seismic sensing, and we are using MPU 6500 accelerometer communication over a high-speed SPI interface. We choose to focus entirely on the Z-axis, sampling it exactly at 1 kHz using a hardware timer interrupt. To ensure our data reliable and securely stored, we integrated RTC, as you can see, R2C module via I2C for precise time stepping, and micro SD card module, as you can see, using SPI and FATFS library to log every single seismic event into a CSV file.
Let's talk about the firmware and math behind the detection. The STM32 continues to read the MPU 6500 and push the Z-axis data into a 2048 sample circular buffer. Instead of saving everything, the system calculates a dynamic envelope of the vibration. If this envelope crosses our 50 milliforce threshold, it triggers an event. Once the vibration stops, the real heavy lifting begins. The MCU takes the snapshot of the buffer and runs a custom Radix 2 Cooley Turkey fast Fourier transform. To keep the processing extremely fast and efficient, we avoided floating point math entirely. Instead, we implemented the FFT using Q17 fixed point arithmetic with pre-calculated sine and cosine lookup tables. This allows the STM32 to instantly find the dominant frequency of the vibration before returning to idle.
To make this data visible, we built the Seismic Mission Control Web dashboard. Originally, as you can see, the firmware just sent human-readable text over UART, and we just started, and it shows here. But the power a live responsive UI, we had to upgrade our architecture to stream JSON objects. By emitting JSON to STM32 can now send continuous 50 millisecond envelope updates for the live scrolling chart, as well as the full 128 bin spectrum array for our bar graph. When we hit the table, the LED graph shows, and also in terminal we can see the changes. And for live user interface, we connected and we can see the values also here. Because we use the web serial API, there is no need for intermediate Python scripts or local servers to bridge the connection. The browser connects directly to the STM32's COM port, parses the JSON streams natively via JavaScript, and renders the telemetry, event logs, and FFT spectrums using chart.js.
Before starting the live demo, we would like to briefly explain the motivation behind our project. Professional vibration analysis systems are usually expensive and complex, so our goal was to design a low-cost, portable, and real-time embedded vibration analysis system. In this project, we combined an STM32F407 microcontroller, an MPU 6500 motion sensor, DS3231 real-time clock module, and a micro SD card module. The main purpose of the system is not only to detect vibration events, but also to analyze their frequency characteristic using FFT and visualize the results to a web-based dashboard.